going to get started with the next session, welcoming Perry Krug again, Senior Solutions Architect here at Couchbase.
Thanks again, Ali. Thank you all for joining me and or staying here from the last session. For those of you just joining us, my name is Perry Krug. I'm a Senior Solutions Architect here with Couchbase. And the focus of this presentation is going to be an introduction to sizing your Couchbase cluster. I wrote a series of blogs that are available online, going into many of these same concepts much more in-depthly, providing some specific recommendations, and I encourage you all to go and check those out. This will be more of an introduction to those concepts. So to get started, sizing Couchbase is going to be directly related to the performance that you receive out of it. And sizing is one of, if not the most important factors to administering and properly deploying and managing a Couchbase cluster. In previous versions, this was also directly related to the stability you would get from the cluster. We're doing more and more from a software perspective to make it more resilient to under-provisioning and undersizing. But performance certainly is going to be most critical to have sizing correctly. So the major points that you want to try to work towards, that you want to size for, is to make sure the majority of, if not all, of your reads are coming out of RAM, and that you have enough I/O, be it disk and network, to serve your writes, and then mitigating the inevitable failure, and we'll talk about that in a little bit. The other aspect of sizing is scaling out. So if the application with very high throughput is accessing a multi-node Couchbase cluster, each one of those nodes only needs to be responsible for holding, processing, storing, writing a small percentage of the data. The more nodes you have, the smaller that percentage is for the entire workload. Excuse me. So we typically talk about there being 5 factors of sizing a Couchbase cluster. And these 5 factors, one of which is really going to determine how many nodes you need. So RAM, disk, CPU, network, and just the general distribution of data across the cluster. One of these is going to say you need X number of nodes in order to have enough RAM, or in order to have enough disk, or in order to have enough CPU, and that's what's going to be the determining factor. That's what's going to dictate how many nodes you need, really based upon the resources and the hardware and the systems that you have at your disposal. We typically size a data set and a workload per bucket. So if you're running multiple buckets, multiple applications or workloads on a Couchbase cluster, you need to aggregate all of those so that the underlying system has enough capacity and performance to supply all of them. So taking a look at these one by one, our focus for RAM is to keep the working set of data in RAM. In some case, we'll talk about that. The working set is going to be your managed cache, your document cache, which is a combination of the metadata, the fact that you want some active and replica data in cache at the same time. That way, if you have a failure and you go to the replicas, you're not just going to disk for every request. And then also new to 2.0, this idea of having some RAM available for buffering and using the operating system to cache the I/O access to your views has proven to be a very good performance booster until we're able to programmatically and manually cache those ourselves. Digging in a little bit to working set, this becomes very application specific, very dependent on your application and your workload. Taking 3 examples, in many social games, many very large scale consumer applications, you may have hundreds of millions of users present in the system. Very likely only a small percentage of those are actually working with your application at any point in time. And so that's really what your working set becomes. That's what you need to have enough cache for. And when a request comes in for a piece of data that's not in cache, it's going to be brought up into RAM and kept in cache as long as it's eligible for. So that first request, that first user login or user load from someone who hasn't come back in a while may take a little bit longer to come from disk, but all of the interaction after that for that user or that document is going to be fed out of RAM. And we automatically take care of migrating data or older data that hasn't been accessed out of RAM. Working our way across some more typical business applications that have smaller data sets or smaller numbers of users have a working set that's a larger percentage of their overall data set. And so having enough RAM on a percentage perspective to cache that is important for that application. The other extreme of which being many ad networks have random access to any document in the system and therefore try to enforce and keep all of their data cached in RAM, their working set being an exact copy of their entire data set. So this really becomes a question that you have to ask yourself and how your application expects the performance of its requests to be. Something else I wanted to say about that. Many times we're asked what is the recommended or optimal percentage or ratio of RAM to disk, and as you can see here, it really depends on your application, and there is no optimal one number that's going to suit everybody. So in a social game, your working set may only be 1/10 of your overall data set. In an ad network, it may be 100%. And so knowing how your application expects to perform is important to sizing that. And then additionally to that, outside of our managed cache, is the idea of leaving some space available for the operating system to cache the I/O of those view requests if you're using views and indexes. We're still characterizing this a bit ourselves. We're still understanding the effect here, but we've seen a significant drop in latency, a significant increase in throughput when there is some amount of RAM available outside of the cache, outside of our cache available on the system to buffer these reads. Moving on, disk sizing is a combination of or a conglomeration of both space and I/O. Space is usually not a huge requirement, but if you're in, for example, in an Amazon EC2 where you're constrained by the amount of disk space you have, making sure that you have enough becomes an important factor. If you're in your own data center and you have multi-terabyte disks, it's unlikely that that space is going to be a problem for you. But keeping in mind that the entire data set, actives, replicas, and the indexes need to live on disk, keeping in mind that you may be doing backups of that data on the same disk drive, that you need to do compaction of our append-only disk format, which means that your space, your disk utilization is going to grow and shrink over time, and you need to make sure you have enough space for whatever that peak of that is. Disk I/O becomes a much more important factor, depending to some degree on the application, whether it's read-heavy or write-heavy or a mix of both. But in almost all cases, disk I/O needs to be taken into account to some degree. The more you're reading from disk, the more your working set does, or the more your working set doesn't fit into RAM, the more read requests are going to come from disk, the more that disk I/O is going to be important for performance. The more impact anything else that contends for the disk I/O is going to have. So compaction and backups, rebalancing, those sort of things should be operating online without any impact to your application in and out of RAM. But if you're reading a lot from disk, you're going to see more of an impact of those, and that may indicate a different sizing for you, more RAM, or may indicate using faster disks such as SSDs so that you can support all of that disk I/O that's going on. Spoke a little bit about this already. Those disk writes are buffered into RAM. It's the expected behavior of Couchbase not to have to make every write that goes into RAM to disk at the same time to allow a queue to grow and shrink. But it's important to make sure that there is enough capacity over time to keep your sustained write rate going down to disk. The throughput is certainly going to be affected by the speed of those disks. SSDs are better than fast spinning disks, are better than the elastic block storage in Amazon. In many cases, you don't have a choice. In many cases, you have to operate within whatever framework and environment you have available, and that just means that you may need more or less nodes to get the overall aggregate disk throughput. What else do we have here? Generally plan on about 3 times the amount of space as your data set is. This is to take into account replicas, take into account the need to do compaction, the fact that the disk file will be growing and shrinking from our append-only format, the backups, all that other stuff. You don't want to run out of disk space. And so having more and having some extra is always a good idea. In 2.1, we introduced the ability to have multiple reader and writer threads. Previously to that, there was a single thread for reading and a single thread for writing per bucket. We introduced multiple, and by default, we have 3 now. Over time, that will change and become more dynamic. So in most cases, you don't need to tune that, but keeping that in mind, if you have a very write-intensive application, it is there and available. For CPU sizing, moving on, CPU is generally not a huge consideration for us. RAM and disk certainly are much more important, much more impactful. But again, understanding how your application is using Couchbase, understanding what components of Couchbase you're using may lead you to need more CPU than less. For example, in our older versions, 1.8.1, we could really get by with just about 2 cores of CPU providing very, very good performance. In 2.0, when you start to add views, you start to add cross-data center replication, you start to add the compaction of data on disk, we make use of and are benefited by having more cores. And so we recommend now starting with 4 cores as a minimum and adding 1 per bucket that you have, adding 1 per design document of views, adding 1 per cross-data center replication stream, making sure that you still have it to provide you enough CPU for the whole system to operate. And then lastly in this, or almost lastly in this line, network is number 4 for a reason. It's very rarely an impact. If your application is such a heavy load that you're going to be saturating your network bandwidth, then it becomes much more important. If you have an application that needs the very lowest of latency, network is going to be the biggest factor there. We have a benchmark that we did with Cisco showing 10 gig networks providing sub-100 microsecond latencies end to end, whereas single gigabit networks are about 500 microseconds. Amazon is up to about 2 milliseconds of latency. And so if that as part of your application becomes a critical factor, the network is going to be the determining factor for latency that you get back from Couchbase. And keeping in mind and thinking about all of the things that go into the network. So every write is going to be replicated as many times as you have replicas. Reads are not replicated. Rebalancing, as you do a rebalance, is going to use bandwidth on the network. So if you're already at capacity, that may have a detrimental effect. You want to make sure you have some overhead for that. Again, if you're in very, very high scale environments, and for us, this sort of high scale is on the order of hundreds of thousands of operations per second. If you're in the few thousand, the few tens of thousands, network is probably not going to be a major factor for you. Just some of the things to always keep in mind about networks. Couchbase wants to have the lowest latency, the highest throughput LAN between clients and servers, between our servers, making sure if you can to eliminate any router and switch hops. If you are going to deploy Couchbase across a firewall or have your clients out in some DMZ, the functionality will be there. You just have to understand that it's going to be a higher latency. And if you need lowest latency, you need to keep things as logically close together as possible. We had a customer a while ago asking why were some of their Couchbase clusters, some of their Couchbase nodes responding in lower, higher and higher latencies. Some things were timing out. Found out that a Hadoop cluster was running on the same switch and saturating the network bandwidth. And so it wasn't until we started to look at, well, we expect Couchbase to return this quickly, and it's not. There must be something else in the environment or something wrong. And so we found packets getting dropped on the switch. We found a whole set of Hadoop nodes running their intensive MapReduce jobs. And by moving them to separate switches, everything was fine with Couchbase. The last factor that goes into sizing is just about data distribution in general. We are a distributed system. We are replicated, highly available. One node is a single point of failure. Nobody goes into production with that. But many people or many customers think that 2 nodes is sufficient. 2 nodes gives you replication. Why would there be anything more that you want from that? When in reality, if you lose a node, now you have a single point of failure, and you have to recreate not only its data set, but the replica copies. If you want to do an upgrade, you may have to remove 1 node, leaving you at a single point of failure. If you need need to grow beyond 2 nodes, you're going to have to use just those 2 to send all of the data onto your growth. So we recommend our customers to have at least 3 nodes, regardless of how big they are, regardless of how much data you actually have, at least 3 nodes in production to allow you to do upgrades, to allow you to sustain the failure of one node, to allow you to have automatic failover kick in if one node goes down. And many of our applications need more than 3, but that should be the absolute minimum that you go with. So to recap kind of the introduction of sizing, we talk with our customers about analyze a system around the 5 factors of RAM, disk, CPU, network, and just the distribution and safety of data. Depending on your application, depending on your workload, depending on your environment, one of these is going to dictate a certain number of nodes, and whatever the highest number there is the number of nodes that you need to go to. For example, if you have a relatively small amount of data, but with a very high write workload, you may not need a lot of RAM, but you are going to need a decent amount of disk I/O, and that may mean 5, 6, 7 nodes just for the disk I/O, even if their RAM sizes are relatively small. On the other hand, if you have a large amount of data that's read-only, you're going to want to have more nodes that to get the amount of RAM you need, even if the disks themselves are not very heavily utilized. Any questions on this stuff up to now? I'll take questions at the end, but I like to stop in the middle. Yes? Sure. So the question was around the number of buckets. We, at a software level, limit it to a maximum of 10. Technically, that can be overridden, but don't. There is an unfortunate amount of overhead per bucket that we impose today, really regardless of the load you're putting on them. It has to do with the statistics monitoring and heartbeat checking and tracking. We'd like to and plan to in the future be able to optimize that further and support more and more buckets. In reality, many times I find customers who think they're going to need more buckets are thinking about buckets in the wrong way and are thinking about using a bucket per table or a bucket per group of data, when in reality it's better to aggregate all of that into a single bucket or a few buckets. Most of our customers are operating with 2 or 3, 4 buckets for a single application. The one exception to that really is if you're offering a service to your internal or external customers and actually have the need for distinct buckets. In that case, you can get away with up to 10 if you have some decent hardware, CPU, and disk I/O. It may be more beneficial to run multiple smaller clusters, each with a few buckets on them. We can't tune that today. That's one of the things we'd like to be able to. We've got some ongoing work to be able to support hundreds of thousands of buckets, but it's just not there yet. More buckets is not going to change your performance. There's no performance difference between having all your data in a single bucket or having it split into many. So if you need more buckets, you are going to need to have more clusters. Every bucket is spread across every node, so even adding nodes is not going to decrease the load that every bucket puts on those nodes. Is there a question over here? For high writes, you're going to need more nodes for more disk throughput. And you want to be able to spread those writes out over as many nodes as possible so that they all handle them in parallel. They all process them in parallel. 1,000 writes to one node means one node needs to handle 1,000 writes. 1,000 writes to 5 nodes means each one only needs to do 200. And that's really how Couchbase scales linearly with RAM and disk and CPU. Everything is done per node, and so all of the work is distributed across all of the nodes. The more nodes, the less work each one has to do. Yeah, reads are an interesting thing with Couchbase. Because of our caching layer, we can provide very, very high throughput with low latency in a small footprint. So if you have a very read-intensive application, you may not need many nodes just to support the reads. You'll have to think about how much data do I have, what are the writes, and all of that. But one of the characteristics, and Stephen spoke about that in his presentation, was the fact that a static Couchbase configuration, a static cluster with a static set of data, can handle an enormously high load of reads to it. And if an application is spiking and peaking just from more application load, you're not necessarily going to need more Couchbase nodes to handle that. So most of our customers, actually I think I talk about it in a minute, most of our customers scale because of the data, not because of the read workload. Okay, so I mentioned this, I just have another slide in here to recap. But at a minimum for hardware, we recommend at least 4 gigabytes per node. That's really to support what Couchbase does itself. On top of that, you're going to add the amount of RAM you need for caching. At the disk, we recommend using local storage, giving you true distribution and shared nothing rather than going back to a single SAN. SSDs do give quite a boost, both for read performance and write performance on the disk. I typically recommend, if you're going to use RAID for throughput rather than for redundancy. Couchbase has its own replication inside of a cluster. You don't necessarily need every write striped and mirrored on the disk. Some customers prefer to, so that they can lose a disk and swap it out. If you need the best performance at disk, you're going to get that from RAID 0 or 10, not from 5. And then CPU, that should say 4 cores. CPU starting with 4 and going up from there. 4 should really be the minimum for Couchbase to function. I'll come back. We are multi-threaded in many places. We will make use of as many cores as you can throw at us. Most of our customers are in the 8 to 16 core range. Some are upwards of 24. Very, very few, if none, are in the kind of the Oracle or MySQL 64 core systems. They're just not necessary for what we do. I don't know exactly what the impact of hyperthreading is. I don't know if we have a recommendation one way or another. We want to see more cores that we can spread the threads across. So let's take a look at from a different perspective, the use of functionality, the use of different features and workload on how that's going to impact your sizing. So, excuse me, adding views, adding indexes, these are mostly going to have CPU and disk I/O sizing impacts. They're not going to affect the amount of RAM, aside from leaving that RAM as a buffer for the file system I/O. Indications of needing, of this impacting your sizing more or needing to do something. Generally, if the indexes are not being kept up to date, if you see writes going in, that the eventual consistency between those writes and the index updates is growing and growing, that's an indication that you don't have enough disk I/O or CPU, most likely disk, to keep that updating fast enough. And making sure that you're following our best practices in excuse me, how those views are written, adding more nodes, potentially separating the indexes onto an SSD that will allow them to be updated faster. All of these things can mitigate the impact. Adding cross-data center replication has its own impact. At the moment, it's fairly CPU intensive, and this is something that we're working on changing and reducing over time. But you're going to use more disk I/O as well. Every write down to disk is going to be a read to get sent over to the other cluster. And if you are aggregating data from multiple clusters into one, or doing bidirectional replication, you obviously need enough RAM to hold whatever workload your aggregate data set is. It's fairly easy to see the rising cross-data center replication queue within the metrics, within the bucket metrics. And so if that's growing or if that's larger than you really are comfortable with it being, adding more nodes will parallelize that more. All of the cross-data center replication is parallelly sent from the source, parallelly received on the destination, and so more nodes in both places will increase the speed at which we can do that. I generally see between 2 and 5 5,000 ops per second per node for cross data center writes. That should be a range that you're expecting to see as well. And depending on your CPU, be it much higher, you can add more replication streams. If it's much lower, you can reduce those streams to not have as much of an impact on the CPU, but you're not going to be able to get data across as fast. Mentioning this earlier, as your workload grows, the biggest effects on sizing really are going to come from more writes. More reads, if it's on the same data, will not need more nodes. You'll be able to serve many, many thousands, many hundreds of thousands of operations per second across a cluster if those are reads and those reads are coming out of RAM. Now, if more reads means you're operating on a bigger data set and therefore your working set increased, that's going to require more RAM to cache more of that data. More writes will almost always require more disk I/O. If your current system can sustain that, great. If not, you're going to need to add more nodes or add SSDs or make those nodes faster. Generally, our customers don't scale the number of nodes based upon the workload that they're putting on it. If that workload is constantly increasing because their application is, then certainly that's where you scale. But unlike MySQL, unlike MongoDB, where more reads really needs more nodes, you won't find the same thing with Couchbase. We've done a decent job and are doing more and more of a job of publishing sizing calculations, recommendations, guidelines, and so keeping a constant review of that, making sure your data size in production, your workload in production matches what you expect the sizing to be is an important part of monitoring and administering Couchbase. I've seen many an occasion where Couchbase just keeps working for months and months and months and nobody does anything to monitor it, and all of a sudden you realize that you've only got 10% of your data cached in RAM. Your application has actually been slowing down this whole time, but nobody noticed, and then it's much harder to get out of that. Whereas if you were prepared for and monitoring and understanding ahead of time, adding capacity and growing into it is going to give you a much better, smoother experience overall. So that was as your workload grows. As your data set grows, you're definitely going to need to scale more. More data, your metadata usage in RAM is going to grow. Your working set will be increasing. Your working set may actually not be increasing. Your working set percentage may be staying the same, but just making sure that you have the right amount of RAM to hold that working set as you add more and more data to the system. The indications of this are usually a resident ratio dropping. That's the percentage of data that you have cached in RAM versus on disk, and or your cache miss ratio rising. That's the ratio of reads that are being served from disk as opposed to from RAM. And again, revising your calculations, making sure that you're using Couchbase for the data that it needs to be used for, that you're not leaving data in there that you're never going to access or that's orphaned or stale or historical or archival that you don't need our resources for. So using things like expiration, using things like periodically cleaning up data that doesn't need to be stored in Couchbase, all of that will lead to a proper sizing and allow you to stay within bounds. From a rebalancing perspective, certainly rebalancing, it puts more load on the cluster. We're moving data around, that it has to use more disk, more CPU, more network. A properly sized cluster really should have no impact when you do a rebalance. If there is an impact, it's either something that we want to improve and resolve, or is an indication of undersizing. And so if you're already reading a lot from disk, adding more disk I/O to that because of a rebalance is going to impact that. And so you want to make sure that your sizing not only takes into account what you're currently doing, but also that you haven't maxed out the system to the point where you can't do any more with it. Rebalance only happens when you add or remove or fail over nodes, correct. We're not doing any rebalancing unless you trigger it. Okay, so the other part of, or the last part of this is really about monitoring and growing. And Anil's presentation later on today will talk much more about monitoring a healthy cluster and all of the different metrics that you have. But the way I typically talk about and discuss with customers is monitoring for sizing. So monitoring your RAM. Do you have enough RAM? Is it sized appropriately for the data set that you have and the workload that you have? Same thing for disk, same thing for CPU and network, and making sure that if these indicators are showing you need more data, or over time you're growing into and your tracking indicates that in a couple weeks, it's going to be better to add that capacity ahead of time. So Couchbase is completely shared nothing. Almost everything, and I have to say almost, but almost everything scales linearly. And so needing more RAM is much easier to add more nodes than it is to try to increase the capacity of each individual node. The incremental increase within a node is not going to give you as much benefit as adding another node. Going from spinning disk to SSD is going to speed things up, but you'd probably get more of a boost by distributing the load over more nodes. And there's a sliding bar to be had. So as you get into 20 and 30 node clusters, certainly doesn't make sense to go to 50 and 100 node clusters. But if you're operating at a relatively small scale, 3, 5, 10 nodes, you're going to be better benefited by adding a few more than by trying to incrementally increase the capacity of each one of those. And that's what that was. And certainly understanding how your growth is proceeding, how your application is growing, how your data is growing, how your workload is growing, and preparation is the best cure. Preparation is the best way of ensuring that you constantly have enough capacity and that you're not going to be impacted by needing to grow or by the inevitable failure. When a node fails, you need to do a rebalance. You need to recreate some of that data. And so you don't want to be in a position where one failure actually makes things even worse. So to start to wrap up, sizing can be a tricky business. You can only do so much on paper. You really need to see how that manifests itself in your own testing, with your own object sizes, your own hardware, your own resources, and then constantly feeding back what you're doing in production into what you expect it to look like. So gathering all of your workload requirements, reading my blogs and understanding how how things impact sizing, reviewing those over and over and over again over every month or every time your application grows, making sure that you're not neglecting the sizing of Couchbase. So test it, deploy it, monitor, and then repeat. Okay, so as I've mentioned a couple times, there's a lot more information, a lot more in-depth in both our documentation and some of the blogs I've written. I encourage you to read them. I also encourage you to give me and us feedback about what is either confusing or left out or what you'd like to see in there. We certainly want to constantly iterate and improve the experience and the information we're giving. So with that, thank you very much.